Alright, this is going to be a video from calculus class. It's going to be problem number 1 from our third test. And since this one's kind of long, I'll probably break it up into 2 separate videos. One will be going over the first half, and then the second one will be finishing off the problem. So, the first problem says to find all critical values for f of x being equal to the square root of x divided by x squared plus 1, and then it wants us to find all maxima and minima over the interval from 0 to 4. Alright, so looking at the first part, it wants us to find the critical values. So to do that, we're going to have to take the derivative. Alright, so we had our f of x being equal to square root of x over x squared plus 1, and we can tell that just right from the get-go that since that is a fraction, if we try to take the square root of 0, that 0 will actually make that equation 0, because the square root of 0 is 0, and 0 divided by anything is still 0. And so we know that is a critical value, since that's an actual 0. And then you would also look to see if it's undefined anywhere, but since we have x squared on the bottom plus 1, if you have a positive or a negative, x squared is always going to be positive, so we know the bottom is never going to be undefined. So we found 0, and that's going to be our first critical value. So from here, we go ahead and take the derivative, and so we're going to use the quotient rule, and that is the low, or the bottom, I'll just say bottom, times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, so now we can go ahead and start working this out. If you wanted to, you could make it a little bit simpler for you. If you wanted to change the powers and all that to kind of save time, I'm just going to go ahead and write this out. So we have our f prime of x being equal to the bottom, x squared plus 1, and that is going to be times the derivative of the top, and so the square root of x is going to give us 1 over 2 square root of x minus the top, square root of x, times the derivative of the bottom, which is just 2x. And that's all over the bottom squared. That's going to be x squared plus 1 squared. Alright, so now we can go through and actually start working this part out. Right here. So instead of writing from the last slide, you can look back at that if you need to. But whenever we multiply that first part out, since we had x squared plus 1 times 1 over 2 square root of x, our x squared plus 1 is going to be going on top. And it's going to be over 2 times the square root of x. And then that's going to be minus our 2x times the square root of x. Basically that's going to be all over 1, and I'm just writing it like this so that we can see it as a fraction. Alright, so we will have that over our x squared plus 1 squared. Alright, so I mean, now technically to do anything with the top portion here, as far as being able to subtract it or anything like that, if you'll notice, on the left we have a 2 times the square root of x in the denominator, and on the right we just have 1. So to actually be able to use those, if we just multiply by 2 square root of x, the top and the bottom, then that's the same thing right here as multiplying by 1. So then we could rewrite that as x squared plus 1 over 2 square root of x minus 2x. Well, sorry, we're going to be multiplying that through. So 2 times the square root of x times 2x square root of x is going to give us 4x from our 2's, the 2x times 2. So that gives us our 4x, and then whenever we multiply 2 square roots, that's going to give us an x. The radical goes away. So it's going to be x over 2 radical x over x squared plus 1 squared. Alright, so the 4x times x, I'm just going to go ahead and write that as 4x squared. Alright, so right here, the numerators on top, we have an x squared plus 1 minus 4x squared. And we can do that because the denominators are the same. So that is going to be equal to negative 3x squared plus 1 over 2 radical x all over x squared plus 1 squared. Alright, so we know that a denominator is, if that one was ever 0, it's going to be undefined. And if that's 0, it would make the top portion undefined. So for that portion of it, the 2 radical x, if we had 2 radical x and x was 0, then that would be 2 times 0, which would give us 0. So 0 there is a critical value. And that was what we solved for the first one when we initially solved it, as far as checking for is 0. So the numerator right here is what we need to focus on. So we're just going to set that to 0. So we had negative 3x squared plus 1 equals 0. Negative 3x squared is equal to 1. So then we are going to, I'm sorry, that's negative 1. So then we divide both sides by negative 3. And that's going to give us x squared being equal to 1 over 3. So then whenever we take the square root, we're going to get x is equal to plus or minus the square root of 1/3. Alright, so This is technically 2 critical values, but since our interval that we were solving for was from 0 to 4, that means we're going to reject the negative 1/3. So we're going to reject negative 1/3, the square root of that, and we're going to keep the positive 1/3. Alright, so now from that we know that our critical values is equal to 0 and the square root of 1/3. And whenever we go to solve for the max and min, we need to keep in mind that our interval was from 0 to 4, and I'll be making another video covering that one.